All right, so now we get to start 3.3. So 3.3, we're going to move on from finding the zeros of a quadratic function to analyzing the graphs of quadratic functions. So you know how we've looked at whether you can have two, one, or two different imaginary roots? Now we're going to look at the pictures of these graphs. So the first thing is you got to know your base graph. So if I was to graph y equals x squared, I would just put in values of x and solve for y. So 2 squared is 4, 1 squared is 1, 0 squared is 0, negative 1 squared is 1, and negative 2 squared is 4. Now, when I plot this on the grid, I'm going to plot this very intentionally. I'm going to start with 0, 0. The reason why is that this is an important feature of the graph. This is going to be what's going to be called your vertex. It is either the absolute top of your graph or the absolute bottom of your graph, or I've got a definition down here, which is that the vertex is the point where the graph turns around. Then from there, I don't even have to look at my table of values to put the rest of the points. So I know that if I go over 1 from my vertex, I always go up its square. So I'm going to go up 1. If I go over 2 from my vertex, I'm going to go up its square to 4. So if I wanted another point, I could go over 3 from my vertex and go up 9. Then parabolas have a very distinct feature. And that very distinct feature is that you'll notice that there was a mirror image happening when you went out from the vertex. So this was my vertex. And then my y values were the same. It was 1, 1, 4, 4. Because parabolas have this mirror image effect. There's this axis of symmetry. There's a line through the x value of the vertex, a vertical line. So if I was to draw the axis of symmetry, it would be a vertical line that travels through the vertex that I could fold this graph over. So this one has an axis of symmetry of x equals 0. So it's always the equation of a vertical line. And what that allows me to do is mirror image my points. So this point would occur on the other side of the axis of symmetry. This point would occur on the other side of the axis of symmetry. And same thing with this point. So when I'm graphing parabolas, I use some features about the parabola to graph it. So we've talked about two of the features. We've talked about the axis of symmetry, and we've talked about the vertex. So this one had a vertex of 0, 0. It had an axis of symmetry of x equals 0. But the other feature is that the vertex is a minimum. And we'd say the minimum happens, it's talking about the y value. So if you're thinking about like a physics kind of graph like this, let's say this was area as a function of length, right? So you get a max area. So this one would be a max area at a length of, let's say, 5 or something like that, right? So we talk about min and max in terms of the y value. So this is a minimum of 0 at x equals 0. Okay, so the minimum value is 0 because it's usually the y or the output of a graph that we generally care about. Okay, so those are the three features you know. If you have an older version of the notes, these might be in a different order, but same content. So the vertex, the axis symmetry, and then whether that vertex is a maximum or a minimum. Okay, now we're going to relate quadratic function graphing to what we did in chapter 1, so our order of transformations. So the first thing we're going to start with is that y equals x squared, or f of x equal to x squared, is my base graph, so there's no transformation. Then we're going to go into A transformations. Well, we know that there's 3 transformations that A can do. When A is greater than 0, you get a vertical stretch. When A is less than 0, we get a vertical shrink. And then when A is, sorry. Oh, I totally wrote that wrong. Sorry, you knew what I meant there. I'm just going to change it. I'm not going to re-record this video. When A was greater than 1, we got a vertical stretch. When A was less than 1 but greater than 0, we get a vertical shrink. And now when A is less than 0, you get a reflection of the y values. Cannot write y's. Y values over the x axis. All right, so A transformation. Now, if we were doing a transformation in chapter 1, we would do A, then we'd do B, and then C, and then D. I want you to notice here that we go A, and then we go HK, right? What happened to B, and then what happened to C and D? Well, H and K are C and D. right? But they're very specific for a parabola that they get a value. And there is no b. And the reason there's no b is that if I tried to do a b transformation, let's say I tried to put a 2 in with the x, well, why wouldn't I just simplify that to 4x squared, right? Why would I have a b transformation when I can just turn it into an a transformation? So the moral of the story is, quadratic functions, we don't do b transformations. We just do a transformations. And so we skip it and we go on to h. This would be a horizontal translation. Horizontal translation, just like last chapter. And it can go right or left. So if it's y equals x minus 3 all squared, it goes to the right. And if it's y equals x plus 3 all squared, it goes to the left. So careful. It appears minus, but it actually has a positive h value, right? So this h value is 3. This one, it was x minus h, so we must have put a negative 3 in for here to make it positive, so this would be h is negative 3. All right, and then we move on to k. K is a vertical translation. So it can move it up and down. So if you get y equals x squared plus 3, it goes up 3, right? The k value is 3, is as it should be. If you get y equals x squared minus 3, it goes down 3, and the k value is negative 3. Why does that matter? Well, because h and k is your vertex. So if I look at an equation like f of x is equal to x plus 4 squared minus 5, without graphing it, so without taking my base graph and transforming it, I could tell you that my h value is negative 4, it went left 4, and my k value is negative 5. Your axis of symmetry always goes through the x value of the vertex. So whatever your x value of vertex is, that is your axis of symmetry. So x equals negative 4. Then your min or your max value is always your y value. So it's going to be negative 5. And how do you tell if it's a min or a max? Well, if your a value is positive, the graph opens up and you get a min. If a is negative, the graph opens down and you get a max. So this would tell me that it is a minimum of negative 5 when x equals negative 4. Then we look to see if the graph has been stretched or shrunk. If a is greater than 1, you get a stretch. If a is between 0 and 1, you get a shrink. So there is no a value, meaning that a is 1. So it's not stretch or shrunk. It's just normal shape. So now what we want to do is take that and we want to graph it. So to graph a parabola, I literally just start at my vertex and then I determine my shape. So this graph is opening up with a normal shape. So I'm going to go over 1 and up 1. From the vertex, I'm going to go over 2 and up 1, 2, 3, 4. From the vertex, I'm going to go over 3 and up 9. Then I'm going to mirror image those points over that axis of symmetry. Done. So that is y equals x plus 4 all squared minus 5. Whoa, that was really wonky. Sorry, I'm not very good at keeping these straight. So this is y equals x plus 4 all squared minus 5. So if you're going to do more than one graph in a grid, you should label it or be very clear about your color choices. Now, I did that straight from the information I knew about the graph. You could have also drawn your base graph, right? You should be comfortable with these as base graphs by now. And then you could just transform points. So you could say, okay, I'm going to take these 5 key points and I'm going to subtract 4 from the x value. I'm going to subtract 5 from the y value, and that's going to move it left and down. All right, next one. So again, before we graph, let's look at the features of the graph. For this one, the vertex. So maybe pause the video and give this one a go. See if you can give it a go. So this gives you the h value of the vertex. So the h value is positive 2. And then the y value of the vertex is here. There's nothing written there. So it's plus 0. So it's a 0 for the y. Axis of symmetry is always x equals the x value of the vertex. And then we have to determine if it's a max or a min. Since this graph is opening down, that means I'm going to have a max. I'm going to have a max of 0 when x is 2. Then is this graph going to be stretched or shrunk? Well, my a value is 2, so that means it's going to be stretched. I'm going to take all the y values and multiply them by 2. So technically, if I was going to do this as a transformation, I would say that I'm going to take this orange graph, I'm going to reflect it, I'm going to stretch it by 2, and then I'm going to move it right 2. So I could take every single point, I could write them over here and transform them. I could do it here. I could take this point, stretch it, reflect it, or reflect it and stretch it, and then move it right too. But what I do, because I know what parabolas look like, is I'm going to start at my vertex, 2, 0. I know this graph opens down and it's stretched by 2. So instead of going over 1 and down 1, I go over 1 and down 2. Mirror image it. Instead of going over 2 and down 4, I'm going to go down 8. Mirror image it. And then I connect my points. So you can do this as a points transformation to keep it purely the same as chapter 1, or you can use your knowledge of quadratics and graph it in one step. Totally up to you. All right, go practice some of those.